Ag Tire Talks Driving Yield Through Tire Technology, sponsored by Michelin Agriculture.
James Tester with Ag Tire Talk here. I'm with Mehari Tekeste. He is the director of Soil Machine Dynamics Laboratory at Iowa State University, College of Agricultural and Life Sciences and College of Engineering. So he's going to talk about all the exciting things he is in the process of researching in the field of really soil compaction and how he is looking into how tires and tracks can not only reduce the soil compaction but improve yields. Thanks for being with us, Mehari. Let's start out. So, like, what are your capabilities at Iowa State, and what are you working on?
Yeah, thanks again, for having this opportunity on your podcast.
Anytime.
So our laboratory, so machine dynamics laboratory at Iowa State, it's in Boone, Iowa,
Uh-huh.
close to Iowa State campus. Uh, we do testing indoor on soil compaction, traction. We also do field tests for measuring soil compaction at shallow and deep profiles and the effect on crop yields.
So really, in a
So,
nutshell, you're getting it from two angles. You're doing the real controlled in-house testing, and then you're also going out in the field, right in the heart of the heartland there in Iowa. Is that correct?
that's correct. Yeah, Iowa State Ag and Agriculture Engineering and Agronomy Farm is in central Iowa. So that's where we do a lot of our field study. Uh,
So let's talk about some of the stuff you're doing in-house. It's my understanding that you've got an artificial soil and you're looking into footprints. Why don't you elaborate on that? Tell us exactly what you're doing.
Yeah, so one of the capabilities that we have built at the Soil Machine Dynamics Laboratory uh, at Iowa State is to be able to measure footprint on artificial soil. So when you look at measurements of footprint on soil, there's no standard.
That is no
Uh,
standard on hard surface either. Good point. So everyone, you can't tell apples to apples. You're right.
Yeah, there's a flat plate is what's published. Even that, there's no standard. Different
Right.
tire manufacturers publish the flat plate on hard surface, but there's no standard on the procedure on how to do it. So what we do in the lab is we try to get a standardized test on a repeatable soil medium, which is the artificial soil.
So what's
So
the
we
difference you're
did
seeing?
go ahead.
Yeah, go ahead. What are the differences you're seeing between the flat plate, hard surface, and the malleable soil when you're doing the testing?
Yeah, so what we found out was when we were measuring a footprint on from tire on soil
Hmm.
was we've done a lot with row crop tractors,
Artificial soil,
wheel and
right?
tracks. And when you measure it on the artificial soil versus a hard surface, the footprint length was 2 times longer measuring it on soil compared to a hard surface.
Okay, so let me be clear about this. So if you've got a specific size, say it's a 480 R50, same air pressure, you're saying that the area is showing almost double on the malleable artificial soil you've got relative to the hard surface. Is that correct?
That's correct. That's correct. Yes. So
Wow.
the data is both for a high tire inflation pressure settings on road speed and the maximum load per tire versus uh, a low field speed and low tire inflation pressure, 26 psi, 9 psi on a mechanical front wheel dual rear tires for 80 R50. We found out that the footprint length increased 2 times
So
for both tire inflation pressure settings.
So why is that? Why are you seeing such a dramatic difference from a measurement on a hard surface versus the malleable soil? Give us the detail on that.
Yeah, that's interesting. So we're learning too, with mechanics of soil and pneumatic tires. What it is when you look at pneumatic tires, they deflect based
Hmm.
on load, tire inflation pressure, and
Amen.
tire configurations or the manufacturability of it. So when you do it on a hard surface, the hard surface does not deflect. Only the tire deflects. When you
Yes.
use tractors in the field, the tire deflects, the soil also deforms. So you're missing that part of the mechanics of tire deformation versus soil deformation when you do it on a hard surface.
How
With
does
with our test, with our artificial soil, which gave us a more repeatable variance of measurements too, very repeatable for every replications.
Amen.
The artificial soil deforms, the tire deforms. So in other words, you're gaining the true footprint characteristics from those two systems, where the tire deflects, the soil also deforms. Uh, in the hard surface, you only have one of the system that deflects, that's the tire.
Okay, so
So
go
by
ahead.
getting this close to a true tired soil field condition, uh, we're able to get one, repeatable test. Two is an accurate measurement of the tire soil footprint,
Amen.
which gave us about 2 times longer footprint from a static loading.
Really exciting news. So let me wrap on this. What are you seeing the difference between the track? Clearly, they have different physical properties. So take it from a regular hard surface to a soil. Are you seeing what's the difference on the track piece?
Yeah, so the study that we did, this was it's getting about 2 years ago now. We compared a row crop tractor, mechanical front wheel, that had dual rear 480 R50,
Standard.
ballasted for planting applications, um, compared it with four track, 80-inch long track, 24-inch track width. Uh, it's the same ballasted for planting applications.
Right. Yep. Apples to apples.
Yeah, apple to apples from the power system or the row crop tractor and then the track system. So the row crop tractor tires, we have two tire inflation pressure settings for road and field. Road was 26 psi and the field is 9 psi, and we compared it with track. Now, when
Okay.
you measure the footprint from track, hard surface versus the artificial soil, the footprint was the same. What
Interesting.
we
So you're
did is
getting
just
double the length on the tire piece, but the footprint's the same on the malleable soil on the track. Is that correct?
yes. So
Wow. That's amazing.
the reason is, the track is a stiff, it does not deflect. So when you're measuring it on uh, either hard surface or soil, uh, what you're getting is just a track length. Now, when you
Interesting.
compare it with the dual tires, uh, at the high and low tire inflation pressures, the low was a 9 psi. Uh, what we measured was on the artificial soil, the contact area with the 9 psi duals had 5% bigger contact area compared to the track
Wow. So
system.
really, at the end of the day, on the malleable surface, at the lower inflation pressures, you're seeing that a standard row crop setup is delivering more footprint area than a standard four-track tractor machine. Is that correct?
Yes, this is from what we measured. for those track and the dual tire row crop tractor, mechanical front wheel drive tractor.
Well, this really is groundbreaking research and amazing. We've never really heard information like this really from someone who's got the statistical background and really all the engineering piece and putting it all together. It's really great to hear. So, let me make sure I've got this right, Mahari. So really what you're saying is that you've conducted research, you've really focused on the footprint piece, and really what you found is all of these measurements out there, if you just take the flat plate compared to real world, it really doesn't give you an accurate assessment when you actually use the soil. When you really get down to the low inflation pressures, oftentimes you can get the a slightly larger footprint on some of the latest tractor and track machines, row crop tractors, right? Using tires at single digit PSI, actually a little bit larger footprint than the track. Is that correct?
Yes, that's correct. That's correct. So what's so interesting is, in the ag crop production systems, uh, tire manufacturers would provide, uh, tires based on the load specifications.
Amen.
So if we look at about 20 years ago when the new tire standards came, IF and VF, where the IF could support 20% more carrying load
Right?
compared to standard radial tire for the same tire inflation pressure, and VF being 40%. It's a measured data based on load deflection measurements in a controlled laboratory measurement.
Yes.
So the tires had to support that. That's the standard.
Yep.
Now, tire manufacturers also provide contact area. It's called gross flat area.
Gross flat plate. Yep.
Yeah. But, those newer tires that came into the market, they tend to have, a larger contact area, more
Yes.
deflection, and they
Amen.
could operate at a lower tire inflation pressure than
Yes.
the standard radial tires. But there's no standard data that you could get to make sure that what's the gain on the contact area? How much are you gaining? There's no standard because a flat plate does not provide that. So the advantage was measuring on artificial soil is you're bringing that piece of the soil part into the picture. The reason that those tires came to the market are more for uh, reducing soil compaction, gaining traction, and supporting standard load increments. But those two pieces that you get for soil compaction and traction, there's no soil test data. Now, the
Perfect.
footprint is where the compaction starts. You have a load. The load is spread on an area on any tractive system, either it's pneumatic tire or track. So if you measure it at where compaction starts at the footprint, you have reliable data to quantify by how much magnitude is an increase in contact area of any technology, either central tire inflated pressure systems where they could change your tire inflation pressure depending on the field speed and load, or if there's a new tire technologies. And the same with track. There are a lot of tracks now, 4-track, uh, 2 tracks, or rubber tracks. Getting an accurate measurements allows both the engineers and growers to get a standard test data.
Right, and they know where they're at. I gotta tell you, this was really an exciting interview for me, really groundbreaking. We've really never, you know, felt that we were getting apples to apples data. We really couldn't compare one thing to the other. To find that you're using a standardized process in soil to really capture the different physical dynamics of the track versus the tire to give us some real world data that's really showcasing that, hey, there's some big differences once you get down to measuring really in a soil environment versus a hard surface environment. Well, all right, thanks again for being on the program with us. And that is a wrap.